Students, today we will see the study lesson number 3, triangles. In this, first I will explain you the theorems. In this video we will study all the concept of this lesson number 3. Okay, first I have taken the remote interior angle of the angles of the triangle. Now what we have to prove? That we have to prove that angle PRS is equal to angle PQR and angle QPR. Okay, now first we will see here see what I will take in triangle. Okay, in triangle PQR. Okay, what we will see that angle PQR plus angle QRP plus angle RPQ is equal to 180 degree. What is the reason behind it? Some of the interior angles of the triangles are supplementary. Some of the interior angles are supplementary. Okay, now next we will study here angle PRS plus angle PRQ is equal to 180 degree. What is this reason? Linear pair. Okay, now when we will compare this equation 1 and equation 2, what we will see here, that angle PQR plus angle QRP plus angle RPQ is equal to angle PRS plus angle PRQ. In this 180 common. Okay, now what we will cancel here? Angle PRQ means QRP and PRQ two sides will be cancelled. Therefore angle PQR plus angle QPR or RPQ, okay, is equal to angle PRS. Remote interior angle theorem we have finished. Okay, that is that exterior angle is a PRS. Understand? Now next we will study here that different tests. Okay, first I will show you. I have taken these two triangles ABC and PQR. What it is here? This angle common, this side common, and this angle is common. Therefore which type of test it is? ASA test, angle side angle test. Now next it is in this both triangles ABC and PQR, you will see that AB and this PQ both sides are common. Okay, this angle and this angle B and Q are concurrent, and this side BC and QR are concurrent. Therefore which type of test it is? SAS test it is. Okay, now next it is here in the third, we will see here that AB concurrent to PQ. Next BC, I will write here A B C P Q R. Okay, BC concurrent to QR, and last AC concurrent to PR. Now all the sides are concurrent, therefore test it is SSS test. Okay, now last area it is, we will see that here are the 90 degree angle. This is A B C P Q R. Angle Q and angle B are concurrent. In this, angle Q and angle B are concurrent, AB and PQ are concurrent, and AC and PR are concurrent. Therefore the name of the test is an hypotenuse side test. What is the name of this? Hypotenuse side test. Understand, student, this? Now next I will explain you, if the two sides of the triangle are concurrent, then angles opposite to them are also concurrent. Okay, now here we will see that isosceles triangle theorem it is. If both the sides are given, then we can, by learning this theorem, these two angles, that is angle ABC and angle ACB, are concurrent. We can show it. Okay, now next it is 30, 60, 90 theorem. Now when we will study about the 30, 60, 90 theorem, in this opposite of 30 degree is, okay, I will write here, this is an hypotenuse. Now opposite of 30 degree, 1/2 of hypotenuse. Okay, next opposite of 60 degree is under root 3 upon 2 hypotenuse. Opposite of 30 this side, opposite of 60 this side, and hypotenuse is this. Okay, when it will prove that? When it is a right angle triangle. Next it is an 45, 45, 90 degree. Okay, in this 45, 45, 90 degree, what? Opposite of 45 degree is equal to 1 upon under root 2 hypotenuse. Okay, 45 degree opposite side this 45 degree opposite side this, and this is an hypotenuse. Okay, so what is an 1 upon under root 2 hypotenuse. Now next it is an, I have drawn here median BD. Okay, when there is an right angle triangle, okay, then median BD is 1/2 of AC. This is an median. Okay, median BD is 1/2 of AC. This is an 1/2. So you can see that this is a segment is divided into half, and BD is the median. Understand, student? Now next point I will explain you that perpendicular bisector theorem. What do you mean by the perpendicular bisector theorem? Okay, in this perpendicular bisector theorem, what we will I will explain you every point on the perpendicular bisector every point on the perpendicular bisector of a segment is equidistant from the end points of the segment. Means what we have to prove? That PA is equal to PB. Okay, in this theorem what we will prove? That PA is equal to PB. This is a perpendicular bisector. AM and MB is an equal, and this is a 90 degree angle. Now next it is an angle bisector theorem. Every point on the bisector of an angle is equidistant from the sides of the angle. Here what we have to prove? That segment AB is congruent to segment AC. Okay, what we have to prove? That segment AB is congruent to segment AC. This. Okay, see, this is a 90 degree angle. Next, how we will prove that? Comparing these two triangles of the congruency. This is equal to this. BQ is equal to QC, or BQ is congruent to QC. AQ is common. Okay, both side. An angle ABQ and angle ACQ is congruent. Reason behind it is a 90 degree. Therefore, AB is congruent to AC. Okay, in this way we can prove that by angle bisector theorem. Next it is an it's part 2. Any point equidistant from the sides of an angle is on the bisector of the angle. What we have to prove? That ray QA, okay, this ray QA is the bisector of angle PQR. Okay, this ray QA is a bisector of angle PQR. Understand? Now next, last point it is, and now if we see that segment AC is greater than segment AB, segment AC is greater than segment AB, then we will see that angle B is greater than angle C. Okay, you will see that angle B is greater than angle C. Understand? Whole lessons concept I have taken, theorem also I have taken.